Hi, class. Last week, we continued exploring descriptive statistics, looking at measures of spread. So things like range and standard deviation were things that we actually tackled. And we kind of ended everything by looking at what a normal curve was and then the assumptions that we can make about data and its spread when we use the empirical rule for a normal curve. Keep in mind, a normal curve, this is like a bell-shaped curve, more or less. So the empirical rule 68, 95, 99 proves really useful for us. So, like everything we learned last week, absolutely fantastic. We know that 68% of all of our data is going to fall within plus or minus one standard deviation. We know that 95% of all of our data is going to fall within plus or minus two standard deviations. And we know that 99.7%, I'll just shorten it to 99, of our data is going to be captured by plus or minus three standard deviations. So when we think about things, if you're outside of like that, you're definitely an outlier. So one of the quick and dirty rules used in stats is basically anything that's more than plus or minus three standard deviations away from the mean is going to be like bad data. It's going to be outliers that you can just toss out. Um, that's a different rule and a little easier to use sometimes than trying to figure out the interquartile range, multiplying it by 1.5, and then adding that to um, your Q3 or subtracting it from Q1 to see where those numbers fall, and then to look at data outside of that, which is the other way you can find outliers. So that was all last week. This week, what we've got is we're going to be looking at probabilities, and this is everyone's, I think, favorite part of statistics, but it's also like everyone's like worst part. Probability is interesting, and there are lots of examples we can use to illustrate things. But the wording of what is given is so important that what happens is students will find themselves, and quite frankly, even faculty will find themselves misinterpreting the problem and based on their interpretation doing one thing when the problem is looking for another, all because of maybe one word that they missed when they were reading the question that changed like how to look at it. And sometimes it's not even obvious that there was one word that changed it. Sometimes it's just like a comma or a pause can change things. So it can be really annoying and frustrating trying to learn probability, but it's really important, and it's everything we do is based on stuff like this. So now that we've gotten through some of the basics of statistics and learned a lot of terms, we've learned how to use a calculator and whatnot. Now we're going to be looking at just how do we put together these probabilities, especially when you start considering that you can have events that are dependent on each other, or you can have events that are independent of each other. Like everything can change. So like, how does this relate to nursing? Let's say you had a 10-year record of patients in the hospital, and a researcher just says, you know what, I think that 40% of women and 45% of men who have a hospital stay over 5 days, they're going to develop some kind of a non-succumbable infection. And yeah, and then you can use probability to go in and test for some of this stuff, right? Because you can look at the data and see what's actually happening. So at any rate, that's kind of what we're going to be doing here in week 5. So hang in there, and I'll talk to y'all later in seminar. Take care. Bye bye.